So since we have understood the basic operations and structure of a stack, right? In a stack, we have this ordering of one item on top of the other, and we have pop and push, right? While it looks extremely simple on the surface, it is extremely powerful. So we talked about parenthesis check earlier in the chapter as one of the applications, right? Let's go into the details, right? Actually, parenthesis check is far more useful, not just in expression evaluation. For example, if you have 2 plus 3, right? And okay, let me write a more lengthier parenthesis, right? More lengthier expression, I'm sorry. So imagine if I have an expression like this, 2 plus 3 multiplied by 4 plus 6, right? Divided by 2 plus 3 with let's say with this curly braces, right? Here, if you notice, this is also a valid expression in many programming languages, right? Here, instead of having only one type of parentheses, which is your simple braces, right? You also have this curly braces. Okay, there are three types of parentheses which are mostly used. You have this simple bracket. This is called a bracket. These are called curly braces, and you have this square or rectangular bracket type of structure. These are the three types of parentheses that you have typically in most programming languages. For example, if you take C or C++ or Java, right, you have A10 equals to, let's say, 52. So you use this type of parentheses. You use these square parentheses you typically use for indexing arrays, right? So you do use these square braces, and you typically use this. You typically use this in your if-else conditions. If something, right? Right? You use this. Also, you can use this in just simple expression evaluation. In simple expression evaluation, like an arithmetic expression, you can use these simple braces even here. It's also used within the program also, right? Similarly, your curly braces are also used within the programs. For example, if you look at C programming or Java or C++, if something, then you have an open braces, then you have a closed braces, right? Similarly, if you have a function, right? If you have a function f, you have these parameters of the function that are given here. You have these open braces and closed braces here. So parenthesis check is not just limited to arithmetic, where it is certainly used in arithmetic, but it is also used by your compilers. Because look at it, your compiler, which compiles the code that you've written in a high-level programming language, like C, C++. So what does a compiler do? It takes C or C++ or Java code, and it converts into an executable code, into a machine executable code. That's what it does, right? Your compiler also has to ensure that the parentheses in your program make sense. For example, imagine a function like this, right? Let's assume it returns int, right? So you have some function with some parameters. Imagine you have a function like this, and let's say you have an additional parenthesis here. This obviously doesn't make sense, because for this opening braces, there is a closing braces, makes sense. So for this is the closing braces, makes sense. For this is the closing braces. But here you have a closing braces for which you don't have an opening braces. You don't have an opening braces, which means this code has a error, right? This code has a syntax error because you have a closed braces here, but you don't have an open braces, right? So your compiler actually detects all these errors using parenthesis checks, right? So parenthesis check is certainly useful in arithmetic, but it's also useful for compilers to determine if there are some errors like this, right? So now, since we understood that parenthesis check is an important problem both in arithmetic and in programming languages, especially compilers, how do we now check that the parentheses are balanced? So what is the meaning of a balanced parenthesis? When do we say that a parenthesis expression is balanced? We say that it is balanced if for every opening braces, there is a corresponding closing braces somewhere, right? As long as so for example, let's take some examples, right? For example, this, right? And this. Suppose you have something in between, right? You have something here, you have something. So I'm just drawing only the braces part of it and not what lies in between. So this is a perfect example of a balanced parenthesis, because You have an open parenthesis here. You have open curly. You have open simple braces, which is closed here. So these two balance out. You have a square, which is closed here. Makes sense. And you have a closed brace here, which corresponds to this. So this is a perfectly balanced parenthesis, right? Let's take another example. Imagine I have this. Imagine I have this, right? Now look here. This is open. This is open. This is closed. So this part is okay, right? Now I have open here, but look at what happens next. After this open, I got this. You can't close it like this. If you close it here, see, I'm trying to close this curly braces here. But when you do that, what happens to your open braces? You opened these braces inside the curly braces. So you got to close this inside, right? So this is basically an example of an imbalanced parenthesis. This is not valid, right? So how do you check all of this? This is a very important example, right? Your programming languages often encounter into errors like this. Suppose if you have opened the braces but not closed it, okay, or any of these types of errors, both in arithmetic expressions and in code, right? You have to make this parenthesis check to be balanced. So how do you detect these errors and say here is a problem, or here? So what you got to say is, if you get an expression like this, right, you have to say there is an error here, and here is where the error is. You have to also mention where the error is. Here you can say there is no error, everything is okay. How do we do that? Stack is a very popular data structure to solve this problem. Very, very interesting and simple. Now let's see how stack works to solve this problem, right? So let's take a simple expression. I'll give you the intuitive explanation of it first, right? Now let's go step by step. Imagine I have an expression like this. Suppose I have an expression, suppose 23 plus 4, open braces, okay? Okay, so let's assume there is also multiplication symbol here, right? Some simple open braces, right? And some 4 plus 6, some closed braces. Remember, it could be an arithmetic expression or it could be code. For both of them, this technique will work, right? Plus, let's say some open braces, 4 plus 6, again, okay? Some closed braces and closing the curly braces, right? This is a perfectly valid arithmetic expression. Now, how do we check that it is balanced? First thing, okay, I'll tell you the pseudocode, right? So let's assume we have a function called parenthesis check. Parenthesis check. Okay, let's assume this is the function into which you insert this whole thing. Okay. Okay. So you give this whole thing as a string. You give this whole thing as a string. Okay. Let's call this string str. Right. Now this parenthesis check should return 1 if everything is balanced. If it is not balanced, it will say here is an error. What do we do? Let's go through the intuitive part of it. Right. First thing that I'll do is I'll create a stack. Okay. First thing I'll do here is I'll create a stack, an empty stack. There is nothing in the stack here. Okay. Let's assume this is a stack. Of course, you can represent the stack using an array or you can represent it using a linked list. That's up to you. So let's call this stack S. Okay. And I have top because there is no elements. Top is pointing to the bottom. There is nothing in the stack at the start. Now what I'll do here is I'll go through each of these elements. First, I'll pass through each of the characters that I have in this string, right? This is my string. This is my input string that I'm given. First, I'll go here. What is there? There is an open braces. Whenever there is an open braces of any type, whenever I encounter this or this or this, let's assume there are only 3 types of braces. Whenever I encounter an open braces, I will just push it into the stack, right? So I've encountered this. What will I do now? I'll push this into the stack. Okay, now my top will point here. Okay, now my top will point here, right? My top will point here. Okay, so as soon as I see, so the logic here is as soon as you see this, as soon as you see any open brace, just push it into the stack. We already seen the push operation, right? Next I see 2. 2 is not a braces. It's neither of these 3 braces, nor is it any of these 3 braces. It is not an open brace or a closed brace, so I don't care. Next, go here. I don't care. Next this, I don't care. Next this, I don't care. I don't care. Next comes the open braces. So what is the logic here? If you see an open brace, if you see any of these open braces, push. That's the logic, right? This is the logic. The logic here says, if you see any open brace, push it into the stack. So I see this now. What should I do? I should just push it into the stack. Now my top will point here. Now my top will point here. Right? Now I see 4. I don't care because it is not a parenthesis. Again, I see this. So I'm going one after the other in the string. Each character I'm going through. This I don't care. Next, I get a closed brace. Okay, which means one of these 3 came up. Right? So this is case 1. So this is case 1. Case 2. Case 3. What is case 3? Non-bracket, non-braces, non-braces. If you have a non-braces, just simply ignore it. That's what we've been doing, right? Whenever we saw 2, 3 plus, we are simply ignoring it. Okay. So what is case 2? The moment I see a closed brace now, right? So I saw the closed braces. Now what should I do? Now pop the top item and check. I'll tell you what I mean by check here. So now you pop the top item. The moment I pop the top item, what is my top item now? My top item is closed braces, right? My open braces, sorry. My top item is open braces, right? What is the current item? My current item is, so the moment I pop it, what happens? This is no more there. My top now changes to this. So this is no more there. My top now changes to this. Right? I've popped this from the array. Now I compare this. So this is an open brace that I had in the stack, and I have a closed brace now. If the type of the braces match, so this is a simple brace, right? This is your simple like a circular type of braces. So this matches this because they both are the same type. So this should match this matches this, and this matches this. So a simple open braces matches simple closed braces, curly braces matches curly braces, rectangular braces matches rectangular braces. So these two are matching. So no problem. Continue. Okay. You've removed this because this is an open brace that you removed, open simple brace. You have a closed simple brace. That means that's the check that you have to do. Are these two matching? And what is matching? This will match with this. This will match with this. This will match with this. This won't match with this. This will match, this will match, this will match. This won't match with this, this won't match with this. This won't match with anything except this. Similarly, this type of brace will only match with this type of closing brace, not with the other two. So since everything is matching, we are cool. Right? So this went through. Next, you have a plus, just ignore. Case 3, ignore. Next, you have a open rectangular braces. What happens whenever you have this? You push. So I push the rectangular braces. So this is already taken care of. Right? And my top now changes to this. And my top now changes to this. Because I've pushed. Right? Now I have 4. It's not a braces, so ignore. This is not a braces, ignore. This is not a braces, ignore. Next comes this. Now what do I have? I have a closed rectangular braces. Right? I have a closed rectangular braces. Whenever you see a closed braces, what should you do? You should pop and check. When I pop, what happens? I get an open rectangular braces. And I have a closed rectangular braces. Both of them match. Right? So no problem. Okay. So I popped it. Everything looks good. So I have popped it. Everything looks good. Now my top changes to this. My top changes here and this is done. Now this is also processed. What is the next one? My next one is my curly braces. Since this is closed, case 2, it falls under case 2. What is case 2? You pop. So this is what I'm operating on right now. When I pop it, what happens? When I pop it, what do I get? I get an open braces. And what do I have now? I have a closed braces. They both match. Right? So when I pop it, what happens? There is nothing left and my top is no more pointing to any element. My top now points to nothing. Right? So these two matched, so everything went well. So once you reach the end of the string, now there is nothing else to process. You've reached the end of the string and all of the open braces that you popped matched appropriately. So at the end of it, you say everything went well, no problems. Right? Very simple example. So you'll say that this is a perfectly valid parenthesis and the parentheses are balanced. Now let me construct an example for you where it won't match so that you understand how things work. Right? So let me erase this for you now. Right? Let me erase this and construct an expression where things don't match. Right? So let's take it up. Okay. Imagine I have 24 plus 3, right, multiplied by open braces, 4 multiplied by 2, I have closed braces, and let's say I have this simpler expression, right? Now let's see what happens. Okay, let's see what happens now. Now, first, what do? I take one item by one item. I go here. This is an open braces, so case 1, push it. I have pushed it. I'll stop modifying the top, okay, because it's obvious from the diagram here, right? Of course, my top will now point here. Next item is 2. 2 is neither an open braces nor a closed braces of any type, so just ignore. Case 3. Again, nothing. Ignore, 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 ignore. Now, what is this next one? Next one is a open rectangular basis, which means we fall into case 1. What should we do? We should just push it to the stack. So we pushed it to the stack here, right? Now comes 4. It's just it's not an open braces or a closed braces of any type, so we ignore. Then star, ignore. 2, ignore. What do I get next? This is where the fun starts. Okay, I have a closed braces. The next item here is a closed braces. So when you get a closed braces, you fall into case 2. What do? You pop. When I pop, what do I get? I get an open rectangular braces. Right? When I popped it, what do I get? I get an open rectangular braces. So I removed this, I popped it out. What do I have here? I have a closed curly braces. They both don't match. They both simply don't match. Because these are the only 3 possibilities which match. These 2 do not match. Right? You popped it and now you're checking if it's matching or not. It's not matching. The moment you see this, you say, here at this index in the string, there is a bug. Okay, your compiler now says, okay, something is not working out here. There is a problem here. You should not have closed the curly braces here. Okay, actually compilers give this error to you when you're writing this as an expression in C, C++, Java or Python, any of the modern programming languages. The compilers come back to you and say, here at this exact index in your string, there is this problem, right? So whenever you have imbalanced parentheses like this, look at how elegantly stack does it, right? And why does stack work for this case? If you think about it, stack works because if you think about it intuitively, right? If you think about it intuitively, when you're parsing this or when you're going from one item to the other item, whatever is the most recently seen item, that should be closed first. Okay, right? So your LIFO, remember what is a stack? Stack is a last in, first out. So whatever you have seen last should be the first one to be closed. Right? Imagine if you have this type of structure. Here you have a rectangular braces, that is the last one that you're seeing. But you're not closing the corresponding one. You're closing something else, which is not valid. The reason stack works for parenthesis check is because the last item, because of the last in, first out. As you're going from one item to other item in this sequence, the last type of parenthesis that you see, right? If I see a rectangular braces as the last type that I've seen till now, the first type that should be closed should also be this. Otherwise, there is a bug. So it falls into this neat structure of last item that I've seen should be same as the first item that I'll be removing. So last in, first out in the stack structure, because stack is a LIFO data structure, it is working well for us for parenthesis check. Right? If stack does not have the LIFO structure, see, LIFO is basically the structure of the data. Right? This is how the data is organized, or each item of the data is related because of the LIFO structure, right? Because of this fundamental property of a stack that you always push at the top and pop at the top. Because of this structure, it is working out for parenthesis check. And as we told earlier, parenthesis check is not only used for evaluation of arithmetic expressions, it is used extensively by compilers to ensure that your code does not have bugs.